All right, let's take a look at the investigation that you've been working on. They wanted you to start by expanding 2 to the third times 2 to the fourth. Now that means write it out the long way. So what did you do for that? Go. Okay, so this 2 times 2 times 2 represents the 2 to the third. Then what? Okay, so how many total do we have? 7. So exponentially, you would rewrite it as 2 to the 7th. And that's step 1. For step 1b, you have 5 x's, 1, 2, 3, 4, 5, being multiplied. Then you're multiplying by 12 more. Oh boy, they want us to write this out the long way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All that just for you to realize that now how many x's are there? 17, so it becomes x to the 17th. So the purpose here is to discover the property that you can skip the expanded form and go straight to the end. In part C, that would be 10 to the what? 7th. So to generalize, that's a mathematical term for coming up with a formula. What would you say about a to the m times a to the n? Student in the green shirt.
A to the m plus n.
Yeah, a to the m plus n. I'm not revealing your names to protect the innocent. So here we go. Step 3a, 4 to the what over 4 to the what? How many 4s are on top? 5. 4 times 4 times 4 times 4 times 4. On the bottom, how many are there? 2. What can you do next? Cross off some of them or cancel some of them out. This 4 can divide out that 4. This 4 can divide out that 4. And how many are left? 3. 4 to the third. So do you want to skip the next 2? I really don't want to write 0.94 out 15 times. Did you?
Yes.
You liar. Okay, the step is a to the m minus n. Now, all of the problems in step 3 were what we call top-heavy because the exponent on the top is larger than the exponent on the bottom, and we ended up with a positive exponent. In step 3b, you had x to the positive 2. In step 3c, you would have 0.94 to the 10th power. That doesn't happen in step 5 because of this. Watch. You have 2 times 2 times 2, and on the bottom you have 4 of them. So when you go crazy and start canceling things out, top or bottom, do they completely cancel? Which one, top or bottom? Yeah, in the top they completely cancel out and they're gone. And when they're gone, the question is, what's left up there? A 1 over 2. Not a 0, but a 1 over 2. And that's the key here, to make sure that you understand that when you cancel, you're actually doing 2 divided by 2, which is 1. 2 divided by 2, which is 1. 2 divided by 2, which is 1. So the top you have 1 times 1 times 1, which is 1 over 2. All right? In the next one, you would have 5 4s on top, while you only have how many on the bottom? Or you have how many on the bottom? 7. So the bottom outweighs the top. This is called a bottom-heavy problem. 1, 2, 3, 4, 5, 6. Let's throw another one on the front there. So we cancel. We start canceling things. These cancel, these cancel, these cancel, these cancel, these cancel. How many are left and where? 2 are left on the bottom. So it would be 1 over 4 squared. 1 over x to the 5th. And basically, you're just left with that part being in the denominator instead of the numerator. Now, step 6, they want you to sort of come up with that fact by using the property from step 4. For example, in A here, using step 4's property, this would be 2 to the 3 minus 4. B would be 4 to the 5 minus 7. And C would be x to the 3 minus 8. And in all 3 cases, what kind of exponent would you get if you did 3 minus 4, 5 minus 7, and 3 minus 8? What would that exponent be? It would be negative in all three cases. The first one would be 2 to the negative 1. The second one would be 4 to the negative 2. And the third one would be x to the negative 5. And that's where step 7 comes into play. They want you to then tie that in with, what do you do with a negative exponent? How do you rewrite it? Well, that didn't show up very well. If you have a negative exponent, that's not working. If you have a negative exponent, how can you rewrite it? 2 to the negative 1 is 1 over 2. 4 to the negative 2 is 1 over 4 squared. X to the negative 5 is 1 over x to the 5. So how would you write 1 over a to the n? We talked about this yesterday. Yes, sir?
A to the negative n.
A to the negative n. That's a property that exists. You have anything, any base with a negative exponent can be flipped into its reciprocal. Was there a question, or did I clear it up? Okay. All right, next we have power to a power. This is called the power rule, where you have 2 cubed, then being taken to the 5th power. So let's expand what's inside the parentheses. All right? Expand what's inside the parentheses. Give me another way to write 2 cubed. 2 times 2 times 2, that's being taken to the 5th power. So now we need to take the stuff that's in the parentheses and copy and paste it 5 times. All right? So that means to take 2 times 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 2. How many are there? There are 15 2's there now. 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. So we have 15 2's, so you end up with 2 to the 15th power. Did you write x cubed out as x times x times x, and then 7 times from there? Well, did you? No. No. That's okay, I'm not going to either, because that's very long and drawn out, and I think you get the picture that there would be how many x's if we wrote it out the long way? 21. So the rule is, let's write this over here with a big arrow or something like that. What's the rule with a to the m to the n? What do you do? Let's generalize that. That's the word. Yes, sir? A to the m times n. You multiply exponents when it's power to a power. Okay? Ooh, I know what step 9 is. Step 9 says, if you have 2 times 3 5 times, oh, I'm sorry. 3 times, like I said. I messed up. If you have 2 times 3, 3 times, how many 2's are there? So we could call that 2 cubed. All right? 2 cubed. How many 3's are there? 3 times 3 times 3. We can call that 3 cubed. And that's what they're getting at. The rule where if you have a times b both taken to a power, what can you do with that little n? Sort of distribute it. A to the n times b to the n. Now that does not apply with addition. Remember that rule? If it's a plus b to the n or a plus b squared, you do not distribute it. It's only when the bases are being multiplied. Yes? You could multiply the insides, but I don't think that was the point. The point was to try to come up with the property of exponents. Yeah. All right? Finally, in step 10, they want to know why this is true. And did anybody come up with something? What did you come up with? A to the n divided by a to the n. That's a good start. Okay. So you're saying this is the same as this. So obviously Anything over itself is 1. We know that. Go ahead.
N equals a to n minus n. A to 0.
All right. So what he started with is a true statement. Anything over itself is 1. We've been learning that for years, decades, centuries. All right? That's true. The property from above says that when you have like bases, you subtract their exponents. And what's n minus n? A to the 0. So it has been proven. That's an algebraic proof. Talked a little bit about those yesterday, continuing them today. This is Algebra 2, so it makes sense to talk about algebraic proofs. Turn to page 260. It should be on the back of page 259, in case you didn't know that. And all the properties are pretty much laid out there for you. So study those, look at those. We're going to do some examples together that deal with these.